Algebra 2, final review. Question number 29. Find all the real cube roots of point 0.000027. Okay, let's look at the cube root real quick. Well, it's going to be the cube root of 0.000027. We could also rewrite this as 0.000027 to the 1/3 power. And the reason I'm going to write that is because we're going to do it in our calculator. But on a cube root, since the index is odd, remember this is the index, whatever the radicand is going to be the sign of that solution. So since the radicand's positive, my solution can only be positive. And again, if the since the index is odd, if the index is odd and the radicand was negative, the solution would be negative. Okay, so we can put this in our handy dandy calculator. If you don't see it right now, that's fine. So we're going to use the bottom one because I know how to put that in our calculator is easier. So 0.000027 raised to the 1/3 power. We get 0.03. So again, since it's an odd index, there's only one solution. The answer is A. 30. Find the real number root. Well, what's my index? My index is 2. Okay. Even indexes, I can never, ever, ever have a negative radicand. So there is no real number that can be the square root of a negative. Okay, the square root of 36 g to the 6th. Okay, this was, remember our index is 2. So we could really break it down to the square root of 36 times the square root of g to the 6th. When we do that, we're going to get square root of 36 is 6, and the square root of g to the 6th you could think of as g cubed. Just divide that by the index. This divided by the index cubed. Well, since this is an odd power, we're going to have to put absolute value signs around it. Alright, so our answer would be C. And again, we explained that in detail back when we did this chapter. If we ever take the square root of a variable to an even power and it comes out to an odd power, you have to put absolute value signs around it. 32. Simplify the cube root of 128 a to the 13th b to the 6th. Okay, so the cube root 128 a to the 13th b to the 6th. Okay, so let's try to prime factor 128. Okay, 4 will go into 128 32 times. Well, 4 goes into 32 8 times. 4 goes into 8 2 times. How many 4s do I have? I have 3. Okay, what's my index? Well, my index is 3. So let's rewrite this just so you can kind of see it. I've got the cube root of 4 cubed times 2 times a to the 13th times b to the 6th. Okay, remember I told you to escape from the radical, you have to be divided by the index. My exponent divided by the index. So how many times is 3 going to 3? 1 time. So 1 4 escapes and no remainders. How many times does 3 go into, well, there'd be a 1 there. How many times 3 go into 1? None. So a 2 stays. How many times does 3 go into 13? Goes in 4. So 4 A's escape. How many A's are stuck? 1. How many times does 3 go into 6? Twice. So how many B's escape? 2. So my final answer is 4 times a to the 4th b squared times the cube root of 2a. Answer is A. 33. Multiply and simplify. Well, to multiply radicals, my indexes have to be the same. Are they the same? They are. So I can just multiply like numbers. So what is 7 times 6? 42. What is x to the 7th times x to the 8th? That'd be x to the 15th. Okay, so I'm pretty far. But have I simplified it? Not yet. Well, can I find a cube root of 42? Well, no. I could prime factor it to 3 numbers. 7 times 3 times 2. So 42 is as good as it can go in. But how many times does 3 go into the exponent of 15? It goes in 5 times. So what escapes? X to the 5th escapes times the cube root of 42. My answer is A. A lot of you guys would see B, but you've got to simplify. It says it right there. Simplify. 34. Cube root of 162 over the cube root of 2. Are the cube roots the same? Yes. So we can just really rewrite this as the cube root of 162 over 2. The cube root of 81. So let's prime factor 81. So I've got the cube root of 81. Well, I know 81 is 9 times 9, and that is 3 times 3, 3 times 3. So I've got 1, 2, 3. I've got 4 3s. So I could really rewrite this as the cube root of 3 to the 4th. How many times does the index go in the exponent? 1 time. So 1 3 escapes, and what's left? 1 3. So I have 3 times the cube root of 3. So we made a mistake. So there's 2 answers, A or C. Bad book. 35. The cube root of 270x to the 20th over the cube root of 5x. Again, indexes are the same. Again, everybody knows what I'm talking about, the indexes. So we can just say it's the cube root of this big fraction, 270 x to the 20th over 5x, which simplifies to 5 goes into 270. Let's see, 54 times, and then x to the 20th over x becomes x to the 19th. Okay, so let's see if we can prime factor 54. And I'm feeling like we can. So we're going to factor out a 3. 3 goes into 5 1 time. There's 2 left. 3 goes into 24 8 times. So I got a 3 and an 18. Well, I know 18 is going to prime factor to 3 and 6. And 6 is going to prime factor to 3 and 2. So there's all my primes. So I can rewrite this thing as the cube root of 3 cubed times 2, and if you need to put it to the first to make it make sense, 2 to the first times x to the 19th. How many times does the index go into the exponent? On the first one, 3 goes into 3 1 time, so 1 3 comes out. Okay. 3 does not go into 1, so a 2 stays. 3 goes into 19 6 times, so 6 x's come out. 6 times 3 is 18, so 1x is left. So I should have 3x to the 6th times the cube root of 2x. So my answer is B. 36. Square root of 90x to the 18th over the square root of 2x. Same concept. Radicals, the index is the same. So 2 goes into 90 45 times. X goes into x 18th, x to the 17th. So I have reduced it to the square root of 45 x to the 17th. Well, my index, if you need to see, it's 2. Let's prime factor 45. 45 is 9 times 5, and 9 is 3 times 3. So I could rewrite this as the square root of 3 squared times 5 to the first times x to the 17th. How many times the index go in the exponent? So 2 goes into 2 one time, so 1, 3 escapes, there are no remainders. 2 does not go into 1, so the 5 stays in. 2 goes into 17 8 times, so I got 8 x's that came out and 1 x left. So my answer should be 3 times x to the 8 times the square root of 5x. So my answer is A. 37. Cube root of 9 over the cube root of 11. Okay. Well, we can't simplify 9 over 11, can we? But what do our rules tell us? We cannot have a radical in the denominator. So we've got what we call prime factor it. So what I'm going to do is I'm going to multiply the bottom by the cube root of 11 2 more times. And if I multiply the bottom by that, I have to multiply the top by it as well. So the cube root of 11 times the same thing 3 times is going to give us the cube root of 11 cubed, which would just be 11. All right, 9 times 11 times 11. Well, I know that'd be 99 times 11. So it's going to be 99, 0, 99. Add them. 9, 8, 10, 8, 9. So I'm going to have the cube root of 10, 8, 9 up top. And I know that won't prime factor because I multiplied prime numbers, basically. 11 and 11 and then 3 and 3. So my final answer is the cube root of 1089 over 11. B. 38. Okay. The square root of x minus the square root of 6 over the square root of 3 plus the square root of 6. Okay, we're going to use what we call conjugates. We're going to multiply the top and bottom of the conjugate of the denominator. The conjugate means first number minus the second number. Okay, so the bottom now is a difference of squares. So the denominator is now the square root of 3 squared minus the square root of 6 squared, which would just be 3 minus 6, which would give me negative 3 on the bottom. Okay, so that's pretty good. So now let's work on the numerator because we're going to have to do a little bit of work on this one. So let's multiply it through. Square root of 3 times the square root of 3 is 3. Square root of 3 times negative square root of 6 is negative square root of 18. Negative square root of 6 times 3, negative square root of 18. And negative square root of 6 times negative square root of 6 would be positive 6. So this is just the numerator, by the way. So sum like terms, I'm going to get 9 minus 2 times the square root of 18. Can I simplify the square root of 18? Well, 18 can break down to 9 times 2. So what's the square root of 9? Or if you could prime factor it even more. So 3 is going to come out. So we're going to be able to say this is really 9 minus 2 times 3 square root of 2, which would be 9 minus 6 square root of 2. So I have 9 minus 6 square root of 2 over negative 3. So 9 divided by negative 3 is negative 3. Negative 6 divided by negative 3 is 2. So my final answer is negative 3 plus 2 root 2. Answer C. A little bit of work on that one, but nothing major. 39. Add. Well, to add, the radicands have to be the exact same. The whole radical expression, the radicand, the index, all have to be the same. Since they're both fourth root of 2x, we can just add the numbers in front. So 2 plus 6 is 8. Fourth root of 2x. So the answer is C. 40. All right. Again, they have to be the exact same. The index is the same, so we can multiply them, but the entire radicand has to be the same. Since it's not possible. 41. Are they the same? Yep. So what's 2 minus 6? Negative 4? So it's going to be negative 4, fourth root of 5a. Answer C. 42. Okay. They're trying to trick you. What's the square root of 4? 2. So it's really 4 times the square root of 3 minus 3 times 2. 4 square root of 3 minus 6. A. They're trying to trick you on that one. Don't let them. Okay, 43. Negative square root of 5 minus 3 square root of 36 plus 6 square root of 5. Okay, so we can add this and this together. So when we do that, that's going to be positive 5 square root of 5. And again, they're trying to trick us. What's the square root of 36? 6. So what's 6 times negative 3? Negative 18. So the answer is 5 radical 5 minus 18. A. Trying to be tricky again. Know what the square root of 36 is. 44. 20 to the 1/2 power times 20 to the 1/2 power. Our rules say this. If the bases are the same, you can add the exponents. So that's just going to be 1/2 plus 1/2. So it's going to be 20th to the first power, which is just 20. The other rule says if the bases are different but the indexes are the same, it's the same thing as b times a to the x power. Okay, so either way, 44 is going to be C. Okay, 8 to the 4/3 power. Well, let's prime factor 8. That's 4 times 2, 2 times 2. So 8 is really the same thing as 2 cubed. So we could rewrite this as 2 cubed to the 4/3 power. Okay, our exponential properties say if I've got an exponent raised to another exponent, you can just multiply them. So this is the same thing as 2 to the 3 times 4 over 3 to 12 over 3, which is the same thing as 2 to the 4th. And 2 to the 4th is 2, 4, 8, 16. The answer is C. And again, you could also do that pretty easy calculator work too, I believe. You could just put 8 raised to the 4 over 3. I'm not mad if you do it that way either. Okay. 7 minus square root of 2 times 8 plus square root of 2. Okay, we just got to distribute. 7 times 8 is 56. 7 times square root of 2 is positive 7 root 2. Negative square root of 2 times 8 is negative 8 root 2. Negative root 2 times root 2 would be negative root 4, which would be negative 2. So my answer is going to be 54 when I sum like terms minus square root of 2. Answer is B. 47. Okay, difference of squares. You should be able to do this one really quick. Square root of 7 squared minus the square root of 10 squared. So that's going to be 7 minus 10, which is -3. That's a difference of squares. Don't forget it. Difference of squares. Important to know. 48. Write, okay, and a lot of us will screw this up. Write in parentheses 8 times a to the -6 to the -2/3 power in simplest form. So first thing we can do is we can distribute this. So it's really 8 to the -2/3 power times a to the -6 to the -2/3 power. Okay, so let's prime factor 8. We already know that's 2 cubed, so we can rewrite this as 2 cubed to the -2/3 power times a, let's go ahead and multiply. -6 times -2 is 12. So it's a to the 12/3 power. Okay, so when we keep doing this, 2 to the 3rd times -2/3 is going to be 2 to the -6/3 times a to the 12/3. Now we can simplify that, so that's going to be 2 to the -2 times a to the 4th. Well, 2 to the -2, to get rid of the negative sign, we can rewrite that as a to the 4th over 2 squared, which is going to be a to the 4th over 4. Our answer is A. Go through that one again if I went too fast. Make sure you understand how to distribute exponents. Remember the negative sign, just at the very end, it goes on, it flips. If it was a numerator, it becomes a denominator. Okay, solve. Square root of x plus 10 minus 7 equals 5. First thing is isolate the radical, so we're going to add 7 each side. So I got square root of x plus 10 equals 2. We're going to square each side. So I'm going to get x plus 10 equals 4. Subtract 10 to each side, so x is going to equal -6. Now we always just go back and double check, make sure that doesn't make it a negative under the radical. It does not. So the answer is D, -6. 50. 6x equals the square root of 24 plus 12x. All right, let's square both sides. So I'm going to get 6x squared equals 24 plus 12x. 6x squared is 30x squared. So 36x squared equals 24 plus 12x. Now we're going to set, since this looks like now it's a quadratic, let's set it equal to 0. So I'm going to get 36x squared minus 12x minus 24 equals 0. Can we factor out a 12? Yeah, and we can divide both sides of this equation by 12. When we do that, we're going to get 3x squared minus x minus 2 equals 0. Well, what's my a times c value? 3 times -2 is -6. My b value is -1. Two numbers, product of -6, sum of -1. How about -3 and 2? Again, since my a value is not 1, we're going to rewrite this whole thing replacing the b value. So we're going to put that right here. So it's going to be 3x squared. And if you remember what we're doing now, is this. We're replacing this -x with these two factors. So it's going to be 3x squared minus 3x plus 2x minus 2 equals 0. Now we can group however we want. This is what we're going to do. So what can I factor out, or GCF of the first term? 3x. So it's going to be 3x out, x minus 1. What can I factor out on the second term? 2 to get x minus 1 equals 0. So now our distribution property says, or distributive property says, we can rewrite this as 3x plus 2, these first two terms, times x minus 1 equals 0. We know we're going to have roots. We're going to have answers for this and this that solve the equation. And if you remember, we learned kind of a shortcut. For the first term, it's x going to equal negative back. What's the back number? Positive 2. So that's going to be negative 2 over front. So the trick was negative back over front. So negative 2 over the front number is 3. The next one, negative back. So if the back number is negative 1, it would be 1 over front. Front number is 1. So my solutions are x equals negative 2/3 or x equals 1. Let's go back quickly and check to see if either of these make a radical sign. Either make this negative, remember that cannot be negative, and this cannot be negative either. So make sure none of our numbers make that negative. Okay, so I look over here, negative 2/3 and 1 both don't make this negative, so we're okay. But do either of these numbers make 6x negative? Yeah, negative 2/3 does. So guess what? Negative 2/3 does not work. It is extraneous. So our only answer is D. X equals 1. Okay, again, does that make sense? Because you remember, you cannot have the square root of any number cannot be negative. Not a real number. 51. Let f of x equal negative 3x minus 6 and the g of x equal 5x plus 2. Find the f of x plus the g of x. Okay. The easiest way to do this is just write it this way. I mean, some of you guys can see it, and that's cool. But if you can't, I don't want you to mess up. So add them. So I'm going to get 2x minus 4. Answer is A. Okay, 52. Let the f of x equal 3x plus 2 and the g of x equal x minus 3. Find the difference of f of x and g of x. So let's rewrite this. I'm going to write it this way. 3x plus 2 minus, here's the kicker on this one, people. Watch. It's the grouping of x minus 3, right? Because you're really subtracting the expressions. And this matters because a lot of you guys won't distribute this negative sign, right? So I'm going to rewrite this as 3x plus 2. Now I'm going to distribute this negative sign. Minus x plus 3. Because pretend that's a negative 1 and we just distribute a negative 1. Now, sum like terms. So I get 2x plus 5. That's correct. B. A lot of you guys are going to do this. 3x plus 2 minus x minus 3. That's wrong because you don't have a grouped right. So you're going to get 2x minus 1 as an answer. That's wrong. Okay? Make sure you use parentheses if you need to distribute your negative. 53. Let the f of x equal negative 2x minus 7 and the g of x equal negative 4x plus 3. Find the composite of f of g of negative 5. Okay? So what this is saying it's the f of g of negative 5. So what's the g of x? So it's going to be negative 4 times negative 5 plus 3. Okay? If that's confusing, you could rewrite it like this. Find the g of negative 5. So that's going to be negative 4 times negative 5 plus 3. So that's going to be 20 plus 3, which is 23. So the g of negative 5 is 23. So now it's going to be the f of g of negative 5, which is the f of 23. Well, the f of 23, looking at the equation above, is negative 2 times 23 minus 7, which would be negative 46 minus 7, which would be negative 53. Remember, you just work it inside out. That's why I rewrite it always like this, because that helps it make sense to me. 54. Find the inverse of y equals 7x squared minus 3. Step 1. Flip x and y. So I got x equals 7y squared minus 3. Now just solve for y. Add 3 to each side. So I got x plus 3 equals 7y squared. Divide each side by 7. Okay. So I'm going to get x plus 3 over 7 equals y squared. We're going to square root each side. So y is going to equal the square root of x plus 3 over 7. Remember, when we square root something, what do we have to do in front of it? Make it a plus or minus. So y equals plus or minus the square root of x plus 3 over 7. Only answer there is A. 55. All right. X equals the square root of x plus 1. Or sorry, y equals the square root of x plus 1. Well, can x be anything negative? No. So all these graphs don't really help me at all. Okay. Can my x value, can this value ever be negative? No. So the lowest value it'll ever be is what? 1. So just by knowing that, you could eliminate all these. But let's say you didn't know that. What do we do next? Well, we should remember the parent function of a square root looks like that route. Looks like that. But we don't know that either. So just plug and chug. So when x equals 0, y is 1. So that one's in the game. If you don't know what's going on, that one's in the game. That one's out, that one's out. So when x equals 1, y would equal 2. He's in the game. He's out. He's out. He's out. Answer is A. Okay, y equals the square root of x plus 3. So let's make the radical 0, because we know that can be true. So what would make the square root of x plus 3 0? When x equals negative 3, y would be 0. So let's plot negative 3, 0. So he's out. He's in. He's out. He's in. So D and A are out. Okay, let's plot an easy one for us. Well, when x equals 1, 1 plus 3 is 4. What's the square root of 4? 2. Well, we can plot 1 and 2, right? 1, 2. Looks like I got a possible winner. 1, 2. He's out. Answer C. Okay, and that's, you don't remember anything about how we translate graphs or radical signs, and that's fine. Just plug and chug. All right, that concludes this section.